this table gives you the capacity adjustment factor according to weather conditions. Okay, so the weather conditions are given and the free flow speed is given, the normal free flow speed. Okay, you should know the free flow speed and the weather condition. What do we mean by the weather condition? And the value is given as well. Okay, so medium rain, what does it actually mean in the table? Okay, not according to your opinion. My car is wet means it was heavy rain, right? Not like this. So there is already a measurement. You will measure it, and then you will know how much rainwater and in which category it falls. Clear? So this table is for capacity adjustment factor, and this one is for speed adjustment factor for weather conditions. Okay, same things are required here. Then we have the CF is what? Capacity adjustment factor. This one is for incidents or accidents. So what should I know? First of all, if there is no incident or accident, factor is 1. Okay, the factor is 1. You don't need to have a look at it. But if there are incidents, then you should know how many lanes were there normal and how many lanes are closed because of the incident, because of the accident. Okay, maybe the shoulder is closed only, maybe the first lane is closed, maybe the second lane is closed. Okay, and you can see some of the values are written as NA, non-applicable. Okay, or not available. Why is these values not available? Yeah, the number of lanes closed is the same number as the number of lanes you have. That means the road is blocked, right? There is no flow, the road is closed. Okay, there is no operation of traffic on it. Okay, so those values are not available, they are not required. Okay, this is for driver familiarity. Okay, keep in mind again, the incident factor was only for capacity, no incident factor for free flow speed. Okay, driver familiarity, all drivers are familiar. Most of them are familiar, half of them are familiar, most of them are unfamiliar, and all of them are unfamiliar. It's like a subjective assessment. Okay, there is no number here. How many drivers are actually familiar, not familiar? Okay, it's subjective. It's a judgment, opinion. Okay, according to you, how many drivers are familiar or non-familiar? Okay, a rough estimate. And then you can see the factor for capacity as well as the speed. Clear? Clear? Any questions? Okay, which one is left? Work zones. Okay. For work zone, we have to do some work. That's why we call it the work zone. Okay. Other factors were given in tables. For work zone, we have to do some work. Okay. So, first thing we need to calculate for the work zone factor is the capacity of the work zone. Capacity of the work zone to handle traffic, CWZ. So the equation is given on the top. We have two factors in the equation. QDR, meaning Q discharge rate. QDR stands for Q discharge rate. For that we have an equation which is given at the bottom, and we have alpha in the equation. Alpha is the reduction in capacity because of work zone. Alpha is a reduction in capacity because of the work zone. And the value of alpha is fixed as 13.4. 13.4%. Okay. And you can see 100 minus alpha. So we'll put 13.4. 100 percentage, right? So 13.4 means you will put 13.4. That's how you subtract it by 100. Okay? Yeah. Don't do 0.13. Okay. Q discharge rate. So this equation has a number of factors. Okay. The first factor, make it bigger. Okay. The first factor is FLCSI. Factor for lane closure severity index. FLCSI, lane closure severity index. Okay. From where do we get it? We have a table for that. We have an equation as well. but it gives the same value as the table. There is no difference and nothing is missing in the table, so I just put the table here. Okay. So what do we need to get the value of factor? You need how many lanes were there, okay, normal, without the work zone, and how many lanes you have opened in the work zone. Okay, number of lanes normally open and number of lanes still open with the work zone. Okay, so and then you have this ratio which is n naught upon n, but you don't need it. Okay, what do we need? We need this. Okay, so look for these two values and come to the last column. That's it. Okay, this column is there for the equation, we don't need it. We just need the last one. Okay, one thing which I want to point out now, see how many lanes? Three. Normal is 3, right? How many lanes with the work zone? So where is the effect? 3 before, 3 after. What's the effect of the work zone? Huh?
Outside the road.
Outside the road. What's my problem then?
People stuff below.
Huh?
People
No.
on the thing.
Keep on looking this. Okay. We should look it. We are civil engineers, right? You should stop and look. But you don't do this. Huh? Then companies don't have site visits. Go to sites yourself. What's the problem? Okay. Yeah, what's the other reason? Yeah, some people may go, but it will happen on one day. Any other reason?
Working the medium,
Huh?
working with the medium.
So what? You still have the same lanes available to you. What's the problem with the flow?
The width of the
The width of the
lanes are smaller.
lane can be smaller, okay, we still have the same 3 lanes, but they make them smaller because they need extra space. It can happen. This is the effect of the obstruction, the object itself, the work zone itself. It has an effect on the driver behavior because it's happening close to the road, so it has an effect on the driver behavior. Okay, so even if they are doing something on the sidewalk, it can affect you in terms of driving. Okay, because now you see equipments and materials and barriers very close to you. Okay, and you can see this, like you mentioned, even if something is done on the median, okay, you just see the board and there's a concrete barrier which is now close to the road, right? You start to have the effect, okay, you become more careful and so on. So this is that effect. Okay, then we have factor for barrier type, FBR, factor for barrier type. It is a requirement that all work zones must be separated from the road with a barrier. It's a requirement, okay, anywhere you go, okay. So we have a factor for barrier type. Sometimes this barrier can be concrete, okay, it can be made of wood, steel, okay, fiber, a person holding the flag, all these things are there. So we only have two factors, two values of the factor, 0 or 1. If it is concrete barrier, then FBR is 0. Otherwise, it is 1. Okay. Then the next one is FA, factor for area type. You have two types of areas, urban and rural. If it is urban area, the factor is 0. If it is rural area, the factor is 1. Only two values. The next one is the factor for lateral clearance, okay, or the lateral distance. This is the distance between the barrier and the edge of the road, meaning the lane. From the barrier of the construction site to the lane, okay, edge of the lane. And the last factor is factor for day and night, FDN. If you are doing the analysis for the daytime, the factor is 0. For the night time, it is 1. Okay. And I said if you are doing the analysis for daytime, not in daytime. Huh? Otherwise, this factor will always be 140, right? All your analysis are done at night. Huh? Wake up midnight and start solving it. Tomorrow we have exam, right? Okay. So this is when you took the volume. Okay. If the volume was taken during daytime, the factor is for the daytime. If it was taken during night time, the factor is for the night time. Okay. So this you will calculate the value of Q discharge rate from this equation. You will put it on the top, okay, and you will get capacity of the work zone, okay. How do I get the adjustment factor of capacity for the work zone? I take the ratio of work zone capacity and normal capacity. Okay, work zone capacity we calculate it. For normal capacity, how do we calculate the normal capacity? How do we calculate the normal capacity? No one knows, right? Flow rate is what? How do we calculate the normal capacity? No, huh? How do we calculate it? Who will do the design? Yes. Nobody knows, right? Very good. Okay, moving on. So this equation, there is a method. Okay. Then the next equation which you see is the free flow speed of the segment in the work zone, with the work zone. Okay, FFSWZ, free flow speed of the segment with the work zone. Again, you see the equation with many factors here. The first factor is FSR, factor for speed ratio. Okay, so we are taking the speed ratio, speed limit normal upon speed limit work zone. Normal speed limit, work zone speed limit. Okay, so this is FSR, and SLWZ is what? Speed limit of the work. Okay, then we have LCSI. What is that? Yes. What is LCSI? Land something. Severity index. From where do I get it? From the previous slide. There's a table for that. Okay. FBR. Very high. Okay. And how many values it has? Two values. 0, 1. Okay. Factor for what? Dn is what? Dn. Okay. Again two values. TRD. TRD stands for total ramp density. TRD is total ramp density. Now I will use it in some other equation as well. Let me explain. We have a segment. From that segment, you start looking 3 miles forward. Okay, and count the number of ramps you have on your right hand side. From your segment, move 3 miles forward, count the number of ramps you have on your right hand side. Then you move 3 miles backward, and again count the number of ramps on your right hand side.
You mean before the segment or
Before the segment, after the segment. 3 miles after, 3 miles before. Clear? Okay. How much distance you covered? 6 miles.
6 miles?
Okay. So you counted the number of ramps and the distance is 6 miles. Number of ramps divided by 6 is TRD, total ramp density. Okay. Number of ramps divided by the distance. The distance is 3 miles forward, 3 miles back. Okay. Clear? Okay. What else? Yes. So after you calculated the free flow speed of the work zone, then the speed adjustment factor of the work zone will be this rate. Free flow speed of the work zone from this equation and the normal free flow speed. Okay. Now how do we get the normal free flow speed? How do we get the normal free flow speed? All of you should have it. All of you should have it. You submitted it to me. And design?
Spot speed analysis.
Huh?
Spot speed analysis.
Spot speed study. You did it, right? Everybody did it, but you didn't know what you were doing, right? You don't have said, okay, let us do it. Huh? Spot speed study. This is the free flow speed. Okay, this gives you the free flow speed. Okay, clear? Okay. The spot speed study is done when the density is good. There are conditions for spot speed. Okay, so that becomes a free flow tube. So that comes from there. Okay, you take this ratio, it will give you the speed adjustment factor of the work zone. Okay, let us look at this example. We have a long-term work zone. It's a freeway. It has 8 lanes, 4 lanes in each direction. 2 of them are closed, and because of maintenance operations, free flow speed outside the work zone is 70. Work zone has a delineation with what? Concrete barriers. Okay, and these barriers are 0 feet from the lanes. It's a rural area. Critical operation is happening during the day. Critical meaning when we have more volume. Okay, the peak hour. Speed limit of the work zone 45, outside work zone 70, ram density 3 rams per mile. We have to find out the capacity of the work zone and the free flow speed of the work zone. Capacity of the work zone, the equation on the top. To use this equation, I need Q discharge rate, right? Okay, so first of all, I should find out the value of FLCSI, lane closure severity index. I have 4 lanes in each direction, okay, and 2 of them are closed. Okay, so this value, right? Okay, this combination, the FLCSI is 1. Okay. Next thing we need is factor for barrier type. They have concrete barriers. So next thing is factor for area. Area is rural. Okay, next thing, lateral distance between the lane and the barrier. It has no lateral distance. Okay, what's left? Factor for day and night. They are saying the critical operation is during the day. Okay, so the factor is 0. Okay, so what is the Q discharge rate? One 72. Okay, then what is the capacity? 1986. Anybody else? One 1760. Very good. Let's everybody have his own value. Huh? Yes.
The QDR is 1760.
1760. Okay. Okay, this one. 1760. Then what is the capacity? 2032. Okay, So this is the first part of the question. Find out the capacity in the work zone. Second part of the question says find out the speed in the work zone. Okay, for the speed, I need the ratio between the normal speed limit and the speed limit of the work zone. Normal speed limit is 70. Speed limit in the work zone is given as 45. Both these values are given in the question. Okay, so what is this ratio? 1.6. Okay, SLWZ is speed limit of the work zone. LCSI we already know. FPR we know. FDN we know. TRD given. Total ramp density 3 ramps per mile. Okay, what is the free flow speed of the work zone?
Four.
54. Okay. Okay. Moving on, we will do one extra step, which is calculating these ratios for the adjustment factors. Okay, so first of all, calculate the adjustment factor of capacity. Okay, so we already have the capacity in the work zone. Now I need the normal capacity. Okay, so this equation gives you normal capacity. Free flow speed in this case is 70. Okay, normal free flow speed because we are calculating normal capacity. Okay, so we'll take normal free flow speed, that is 70.
Isn't it 49?
Sorry,
Isn't it 49?
no, freeway. It's a freeway. Okay, now the capacity adjustment factor is capacity of the work zone, which is how much? 2032 divided by the normal capacity. So how much is this factor?
0.25.
Point how much? 85. Okay, it was not written in the question, but since we have the values, we can calculate it. Okay, the next one is speed adjustment factor of the work zone. So how do I calculate it? Again, I will take a ratio, right? Ratio of what?
Between the speed,
Which is speed now?
in the work zone,
Yeah, free flow speed of the work zone, which you calculated, and the normal free flow speed, which was given. So how much is that? Any problem? Any question? Clear? Okay. Two things which I want to mention here in this question. First thing is about the speed limit and the free flow speed. In this case, they are same. It's not a rule. It can be different. Okay, speed limit and free flow speed can be different. Okay, clear? Second thing, in the first line, they are saying is a long-term work zone. Okay, All adjustment factors are done for long-term conditions. Conditions which you are expecting throughout the year. Okay, conditions which you are expecting throughout the year. So if this was a work zone which had only 1 or 2 hours of maintenance work, or maybe 1 or 2 days of maintenance work, we don't need this. Okay, we don't need to do all these calculations. Okay, we will focus on the rest of the days, right? We will not focus on those 2 days which have a work zone. Clear? It's for all adjustment factors, whether it's for an incident, whether it's for weather, whether it's for driver population, everything. If it is long term, only then we will apply the adjustment factors, otherwise no. Clear? Okay. In order to calculate the level of service or free flow speed of the highway, you must know these things. You should know the lane widths, you should know the lateral clearance. Lateral clearance means the distance between the lane and the object on the side of the road. The distance from the lane to the object on the side of the road. And that object can be a tree, a pole, a barrier, another building, whatever. Okay, so that distance is called as lateral clearance. Okay.
There is no object. There is no line.
We call it mass. Okay. There is a maximum value after which we don't know. The object is there or not there, but up to that value, if it is clear, after that it doesn't matter to us. Okay. Okay. But the point was, after the lane, what we normally have? The lane, no, between the barrier and the lane. Shoulder, right? The shoulder is part of clearance. Shoulder is part of clearance, not the lane. Okay, shoulder is part of clearance. Okay. If it's a multi-lane highway, you should know the median type as well. Okay, what type of median we have. If it's a freeway, you should know the frequency of ramps. Okay, and we call it what? What did we call it? TRD. Okay. If it's a multi-lane highway, we should know the access points. What is an access point? It's an unsignalized entry point to the highway. Unsignalized entry point to the highway. It's not an intersection. It's not an intersection. Okay? So you can just enter the highway, that's it. Enter like a right turn. Okay? You cannot go to the other direction. And it's unsignalized. Okay? And the people on the highway, they will continue. You have to stop for them. They will not stop it. Okay? The highway traffic will not stop for the person who is entering. Okay? They have the right of it. Right? It's an access point. So then presence of heavy vehicles. Okay? So presence meaning we should know their percentage. Presence means we should know their percentage. Okay? And then we have the driver population factor, the familiarity of the drivers. How many drivers are familiar with the road? Yes. We don't measure it. Like I showed you the table, there is no measurement. We just take an idea. Most of the times all are familiar unless you have a road which is going to another city or something like that. Okay. Most of the time it's a regular route, so everybody is familiar. Unless you have some special condition where people go on special occasions. So then you know that. Okay, if it's an inter-country.
Airport area. Do we consider it unfamiliar because there's a lot of
Some of them are unfamiliar, right? Some of them need to go into work there. Some of them are familiar. So then you have to have an idea. What is the most of the traffic? Is it familiar or unfamiliar? So we have a factor for that condition. If most of them are unfamiliar, then what will be the and so on. Okay? So you can have an idea like how many, if you consider people who are working there, taxi drivers, they are familiar. Okay, people who go on their personal cars, only those you will consider unfamiliar, right? So in traffic you can see their percentage and you can have an idea. Okay, but in the end there is no number. You don't have to measure their percentage. Okay, you look at the road conditions, the traffic, and you start to get an idea about it. Okay, yeah. So we mentioned that we do spot speed studies for free flow speed, right? Okay, but what if I'm doing it for a future highway? Okay, so there is no study possible, right? Okay. Or I don't have the time. The client says, okay, give me the results in 1 day or 2 days. I don't have the time to calculate the number of samples and wait for a free flow condition and so on. Okay, so in those cases we can use the equation. In those cases, not your case. Okay, not in your term project. You already did it. Okay, I don't want to see these equations in the report. Okay, it's not for you. You already have the free flow speed. Okay, so if you don't have it, then you can use this equation. This equation is only for freeways, and we have FLW, which is the factor for lane width. And how do we get this factor? There is a table for that. Okay, and you can see it starts from 12 feet or more, factor is 0, 11 feet, 10 feet. Okay, there is no factor for less than 10 feet for freeways. Why is that?
No freeways with the respective
Why not?
high speed.
High speed. Okay, if we make it too narrow, then the speed would be less. And remember, the freeway is what? Which highway is called as a freeway? No uninterrupted, no intersections. So we are expecting high speed. You cannot do this. Okay, the next one is factor for lateral clearance. This is a value for the factor from this table. So you need the lateral clearance on your right hand side. Okay. And what did I say about the shoulder? It's part of lateral clearance, so that's why they are saying right shoulder lateral clearance. Okay, because if there's a shoulder is in the lateral clearance. Okay, so you should know the value of the lateral clearance and you should know the number of lanes in your direction. Okay, the last factor is TRD, which is what? People are thinking, what is that? It's written there. On this slide it's actually written. Okay, this one is for multi-lane height. This equation is for multi-lane height. Okay, so some of the factors are same. The first one is not. BFFS is not written. Oh my God! It means best friend forever, right? No. Yes. Okay. Okay. So it means base free flow speed. Okay. BFFS means base free flow speed. Okay. So this is the maximum design speed for multi-lane highways. Okay. The maximum design speed for the multi-lane highways. Okay. Then we have FLW. So it's like a standard. BFFS is like a standard speed which you take in your area. Then we have FLW, which is the factor for what? Lane width. Okay. Same factor which we have used for the freeway equation. Then we have factor for lateral clearance, FLC. FLC. The table is different here. Okay. Now look at the first column and tell me the difference between this one and the last one. The last equation also had FLC, right? Factor for lateral clearance. So what is the difference between factor I am using here and the one which I was using there? Number of lanes? More than 10. Okay.
Or less than.
Less than 10.
This one is for the multi-lane and that one was for the freeway.
Very good. Something else. Okay, look at the first column. What does it say?
0.
Don't listen to him. What is the heading of the first one? Come on. Total, okay. And what does this one say? right. Okay, so this is total. This one is total. Okay, right plus left. Right is the edge of the road, and the left is what? Left side you have
Medium.
the median. Okay, so this is the median side.
Median is also lateral.
No, median side, not the median. Okay, median are different types. Depends. It could be part of the clearance or not part of the
If
clearance.
I'm talking like
The median which you normally have, that's an object. So from the lane to the object, it will just have the shoulder. Lateral clearance will be the shoulder. Okay, so you take the value from the right hand side, left hand side, you add them together and then put it in the table. Okay. Okay, the next two factors are for median type, and the last one is for access point density. Okay, the equation, the next two factors will come from these two tables. For median type, we have the first category is undivided, the last category is divided, right? So what do we mean by divided and undivided?
divided.
Divided means what?
There is a barrier.
There is something, there is median, right? Divided means there is the median. Undivided means no median. Okay, and there is a third type as well, which is called as what? Two-way left turn lane, right? Okay, so it's an extra lane. It's an extra lane between the two directions, which can be used by the drivers who want to turn left. Okay, it's an extra lane between the two directions, which can be used by the drivers who want to turn left. So they get into that lane and wait for their turn to turn. Okay, so it's something like this. So you see this portion now. This portion. This is an extra lane. Okay, so a person can stand here. There's a lane here. There's a lane on the other side. While you are standing, you are not blocking anyone. Okay, so when you get the chance, you will take the left turn. Till that time, the traffic will continue. Okay, so this is called as the two-way left turn lane. Okay, the last factor is for access point density. Access point, I told you, unsignalized entry points. Okay, so again you will count them because we need per mile. Access points per mile. So you count them and divide by the distance. That's it. Whatever the length is, 1 mile, 2 mile, 3 mile, doesn't matter. Okay. Segment, yeah. Okay, number of access point divided by the length of the segment. That's it. Okay. Now, the last thing here, if the highway is undivided, that means there is no lateral clearance between the two directions, right? So the actual lateral clearance is what? 0. Okay. So this undivided condition has already an adjustment factor, right? 1.6. Okay. And it will also affect the lateral clearance as well. So it is affecting two factors for the same condition. The highway is undivided, so I have a factor for that. And since it is undivided, its lateral clearance is also 0 on the left hand side. Okay. So it is a duplication of the condition. One condition is affecting two factors. So I don't want to do this. So to cancel out the effect of duplication, what do? Undivided, we keep it. When we go for lateral clearance, we take the standard value of lateral clearance for the left hand side, 6 feet. When the highway is undivided, lateral clearance on the left hand side is taken a standard 6 feet for the left hand side. Then you will add the right hand side as it is. Highway is undivided, right hand side 4 feet, left hand side will be taken as 6. Total 10. Okay? Sorry? Which value? 12 or more 1. 12 or more value is 0. The values are given. You can interpolate, no problem. In all these tables you can interpolate.
So undivided median only for 2 lane to 100. Undivided median only for 2 lane to 100.
No, this is multi-lane. All this discussion is multi-lane.
How come there is no medium format?
You can design it. Nobody will stop it. Nobody will stop you. Don't worry.